So we will discuss about what is sampling and some commonly used sampling techniques. Assume that you have name, age and gender of all the people of India as shown in the table, and assume that each black circle on the left represents each record in the table. So this is the entire population. Now assume that a subset of the entire population is selected for analysis purpose. The selected subset is represented using red color. The process of selecting a subset of the dataset is called sampling, and the selected subset is called a sample. Sampling can be done in two main situations. First is in collection phase, and second is processing requirements phase. So let's look at why sampling is required in collection phase. Assume that you want to know the sentiment of people on the current ruling government. For the same, you survey people and ask for their opinion. Now, India has a population of about 1.4 billion, and so you cannot possibly survey each and every citizen of this country. Besides, what you would do is survey a small subset of people from diverse backgrounds and then consider that to be the representative sentiments of the entire population. Here, you are not surveying the entire population, not because you don't want to, but simply because you cannot. So this is a sampling in collection phase where you take a subset of the total population because of your limitation to collect the data. So what are the pitfalls in sampling? For the same, we will have a look at this famous survivorship bias example. During World War, the flights were returning to the base from battlefield. The red dots are the points where flights endured damages and hits. Now, based on the data, we have to make the flight more robust to incoming attacks. How will we go about doing it? Will you reinforce the regions where there are more red marks? If so, then there might be a potential flaw in logic, because if the flight was hit in any other region, it might be the case that the flight didn't return to the base at all. For example, there is no red marks near the front of the aeroplane where the pilot sits. If the flight was attacked there, the flight might have been destroyed. So in this case, the sample is biased because the sample contains only information about the flight that survived and not the ones that didn't make it to the base. So there are multiple sampling techniques, and we have to choose the right one to avoid such potential pitfalls. So far, we discussed about sampling during collection phase. Now we'll look at sampling for modeling or processing purpose. So if the data is extremely large and you're processing on your laptop cannot handle such large volumes of data. So in that scenario, you tend to take a subset of the data for analysis. Personally, I've done this for preliminary data analysis. So you sample data due to processing limitation. So that's the first reason. The second reason is modeling requirements, which means some machine learning models require the data to be sampled. We will look at this example soon. Also, during modeling, you tend to randomly split the entire data set into two or more parts for train, test, and validation of the model that you built. So these are some of the common reasons for sampling in this phase. So let's get started with the first sampling technique, which is simple random sampling. As the name suggests, in this method, you randomly sample n data points from the entire dataset. So the probability of sampling any data point in the dataset is the same when you use simple random sampling, because you sample randomly from the entire data. This is one of the most simplest and most widely used sampling technique in sampling. So we use simple random sampling when the data is balanced and all the features are pretty much evenly spread out. So say if you are sampling 10 data points from the entire population using simple random sampling, then any 10 point can be selected randomly every time you sample using simple random sampling. So when you are required to take multiple samples of the data, then you have two main choices, which is sampling with replacement and sampling without replacement. Let's start with sampling without replacement. in this method, you have a data, and if you take a sample of the data, okay, now if you take another sample, you can only sample new data points because after the first sample you're making those points unavailable for any further sampling. In other words, you're not replacing the data points back after each and every sample. This is sampling without replacement. So as you keep sampling data, the number of data points available in the pool keeps on reducing. So what is the issue with this kind of sampling? So firstly, the probability of sampling a data point changes after each sample. So this makes it unsuitable for many statistical operations. Also, the memory requirement is more for this kind of sampling because the computer needs to remember the data point that was already sampled to make sure it is not sampled again. The alternative is the sampling with replacement, where you have the data, and if you sample a data point from the pool, those data points are replaced back into the pool. So if a new sample is taken, then the new sample can contain data points which are in sample 1 as well. So this method is more preferable because the sampling probability doesn't change with each and every sample, thereby making it more suitable for statistical modeling. So let's get back to our survey example. Now we are required to predict the outcome of a central government election. For the same, we need to know the sentiment of people across India. We know that the survey is conducted on a sample of people. If each state has equal importance for election outcome, then the sample should be such that equal number of people are sampled from each state. This is called stratified sampling, where we split the entire population into group based on a particular criteria, and then we sample a decided number of data points from each group. So next we'll look into something called systematic sampling. We use systematic sampling when you have sequence data like a time series data, and then you systematically sample the data points, like for example every alternate point or every third point or so on. In the above example, every alternate points has been sampled. Weighted random sampling is same as that of simple random sampling, except that the sampling probability of each data point is not the same. This means that data points with higher weight has higher chance of being sampled than data points with lower weight. Let's see where weighted sampling is of use. For the same, we'll look into how a prediction algorithm called AdaBoost works using weighted random sampling. Assume that you have some data as shown and you want to perform some classification analytics on this data using AdaBoost algorithm. So for prediction purpose, our AdaBoost algorithm works by initially taking a sample of the data using simple random sampling, and then it builds a model on the sample of the data to predict the class. Now this model is used to predict the class of the entire population, which is in the gray color box. It has predicted correctly for most of the points, but has misclassified few data points which are represented in red. Now AdaBoost algorithm takes another sample, but this time it gives more weightage to the data points that has been misclassified, so that the sampling probability of the misclassified data point is more. And again it builds a model for the new sample, and again the new model is used to predict all the data points in the entire data set. This time the new model would have misclassified a different set of data points, so you could see that the red marks has changed. Now another sample is taken with more weight given to the newly misclassified data points in the entire population, and a model is built on the new subset, and the process is repeated n number of times, and then the result of all the models are combined. This method has been proven to be efficient in improving the prediction accuracy. This example is not to explain AdaBoost algorithm, rather to show the application of weighted random sampling and the significance of sampling in modeling techniques. There are many other techniques for sampling like cluster sampling and convenience sampling, which is a variation to the techniques discussed thus far. So this is a gentle introduction to some commonly used sampling techniques, which should help you to explore more. Thank you.